Bismillahirrahmanirrahim. It is NPN transistor characteristics apparatus, and which we have used NPN transistor. Transistor has three pins: base, collector, and emitter. By the base current, we control collector to emitter current, or we can say by the base voltage, we control to VCE collector to emitter voltage. Here in this apparatus we have used different voltmeter and ammeter. This ammeter is milliammeter, which measure the IC collector current, and this voltage is voltmeter is VCE, measure the voltage across collector to emitter. Another side, this microammeter shows the reading of the IB base current, and the millivoltmeter shows the reading of the base voltage, which has been applied across base to emitter. So by the base current we control the collector current, or in other words, by the base voltage VBB we control the VCE or VCC voltage applied across the collector to emitter. As you can see, the VCE collector to emitter voltage range is from 0 to 15, and the base voltage is from 0 to 1.5 volt. So the voltmeter is about 1000 times greater than the base voltage, and the same way the collector current is a milliampere and the base current is a microampere. As you can calculate that milliampere is about 1000 times greater than the microampere. So the main function of the transistor is to amplify the current, voltage as well as power. There are three modes of the transistors. Here, when the base voltage is 0, so the base current will be 0. If you increase the voltage across collector to emitter, so there will be no change and no increase in the collector current. As you can see here, we are increasing the voltage current, collector to emitter current voltage IC does not increases, because the base current is 0 and the base voltage is 0, or the base voltage is less than 0.5 volt, so the base current is also 0 ampere. We have increased the voltage across CE collector to emitter, but IC does not increases because the base current is 0, and in this case transistor is in the cutoff region, and the cutoff region the transistor is completely in off state. So let's increase slightly the base voltage. As we increase from 0 to 5 volt, the base current also increases. So now the transistor is in the active region. By now increasing the VCE, IC also increases. In certain region, 2.5 volt base VCE is 2.5 volt, and this is about 10 milliampere. The IC current is 10 milliampere is passing through here, and the VCE voltage is about 2.5 volt. Let's further increase the VCE voltage. It does not increases the collector current because transistor is now in the active region and the amplify mode. So let's little change the base voltage here. If the base current changes slightly, the large change will be seen in the collector current, because transistor is now amplifying the base current, and we can amplify the base current by the transistor. By the small current we amplify the large current, or other words, by the small voltage we control the large voltage. So let's oscillate the base current. So you can see there is small change in the base current IB, large change can be seen in the IC collector current. Now the transistor is in the active region. In this case, transistor is used as an amplifier. We can amplify the current voltage as well as the product of voltage and current, which is called power. Now the transistor is in the active region or in the amplify mode. So let's increase the base current to 1 voltage. What happens? Now when decrease the collector voltage, we see the IC also decreases. If we increase the VCE, IC also increases. This is the saturation region. Now the transistor is in the saturation region. Because there is a direct relation between VCE and IC, the transistor is now in the saturation region. So there are 3 modes of transistor: cutoff region, when the base voltage is 0, and the active region, and which the IC current is directly proportional to the IB. In the active region, the collector current is directly proportional, depends on the base current. This one is called active region. While in the saturation region, the transistor is fully in on state. And this one, fully on state, and the relation IB is equal to IC is equal to beta. IC does not further valid in the saturation region. And the saturation region, the formula IC is equal to beta. IC is equal to beta, IB will not valid, because this formula is only used in the active region. So this was the simple working of the transistor, and which I have demonstrated the 3 modes of transistor: the cutoff region, the active region, and the saturation region. In the saturation region, the maximum current pass through the collector to emitter voltage, and Ohm's law will valid because the IC is directly proportional to the voltage. Increasing the voltage, current will increases, and decreasing the voltage, current will decreases. This is the cutoff region, this is the saturation region. While in the active region, there is no relation between collector current and collector voltage. This one, as we are not increasing the voltage, but IC stops increasing because IC has been controlled by the base voltage. And this we can produce oscillation. Small change in the base current, there will be large change in the collector current. By the small current in the base, we can control large current of the collector. IC, the way of IC is in this way, and the base is coming from B to E emitter here. And this is the complete diagram. This is the variable IC voltage, and this one is the variable I base voltage. The base voltage is from 0 to 1 volt power supply, minimum, maximum. Minimum is 0 volt, maximum is 1 volt of the base voltage VBB, and here the 0 to 15 volt is the VCE or VCC. It has been applied across collector to emitter volt. Here a transistor is attached to the base. About 1 kilo ohm is applied between the base and the transistor, between the power supply and the base of the transistor. In order to limit the current, it is must this resistor is should be applied between base and the battery power supply, between the power supply and the base of the transistor, in order to avoid the transistor from burning, because we were forwarding for biasing the voltage, the transistor, we need only only 0.7 volt. If you increase the voltage to the base of transistor, a resistor of more than 1 kilo ohm must be connected in series with the base and the power supply, between the base of transistor and the power supply. So if you have any questions and any comments regarding this video, you can comment below this video. So thank you for watching our video.